Using this example, we're going to intro 5.2, evaluating and graphing polynomial functions. So there's at least 3 words there we should define. First, we're going to define polynomial. Here's a polynomial. It's a polynomial because we have this input variable or this independent variable. This one is x. It could be w, it could be n, it could be anything. Any letter you want it to be. This is x. And wherever you see x, or whatever that variable is, it's raised to some number power, right? So this x is raised to the 4th, this x is raised to the 3rd, this x is raised to the 1st. That's fine. You won't actually see that 1. We don't write it. We just assume that it's there if we don't see it, if there's nothing there. So this is a polynomial. You know, you'll have these little numbers out in front that you're multiplying by. Those are called the coefficients of each. The coefficient of x to the 3rd is -5, and so on. So there you go. There's a polynomial. Then something you should know about a polynomial is this guy, the biggest exponent that you see, whatever that turns out to be, and wherever it is, it doesn't matter. Typically, it'll be the first one that you write down. This is called the degree. The biggest power that you see is the degree. Okay, so this is a 4th degree polynomial. All right, so that kind of defines polynomial. Now, evaluating a polynomial, what does that mean? Evaluating just means that we're going to put numbers into x and see what comes out. Okay, so if I wanted to, let's see, we'll write this down in words. So evaluate the function f for x equals 3. Okay, that's one way we could say it. Say evaluate the function f for x equals 3 means what do you get when x is equal to 3? What happens to the whole deal? You could also just say find f of 3. These mean the exact same thing. Find f of 3. Put 3 in for x. So let's do just that. Let's put in 3 for x. F of 3 is 2 times 3 to the 4th minus 5 times 3 to the 3rd minus 4 times 3 plus 8. Okay, 2 times 3 to the 4th is 81. Minus 5 times 3 to the 3rd, that's 27. Minus 4 times 3, we'll just say that's 12. Plus 8. This is 2 times 81 is 162. Minus 5 times 27 is 135. Of course it is. That makes sense. Let's see. Minus 12 plus 8. 8 minus 12 is -4. 162 minus 135. That's 30. That's 27 minus 4, so it's looking like 23. Let's make sure that's right. 162 minus 135. And minus 4. 23. Yes. So f of 3 is 23. That's evaluating. Now, a quick way to do this. Now, the thing that I want you to be careful of is I'm about to get the calculator and show you how to calculator shortcut. But before you do that, the rule for using your calculator is make sure you know what your calculator is doing before you use your calculator to do it. Know that your calculator is doing just this, exactly what we've just done. If you know that, then go ahead and use the calculator. If you don't quite understand this, go back and just drag that little slider down here over and watch that part again. Understand what evaluate at 3 means. But if you understand that, let's just bring the calculator up. We'll turn it on. We'll go to y equals. We'll put a function in there. We'll put this function in there. 2 x to the 4th minus 5x to the 3rd minus 4x plus 8. There's the function. 2x to the 4th minus 5x to the 3rd minus 4x plus 8. Okay, so let's go into, if you press second here, you see it's got an arrow up. That means we've pressed second. And we'll go to graph, which you can't read it here, but it says table. above the graph. And now we can evaluate it for whatever number we want, and we can do that quickly. So we'll ask for, okay, so now we need to change the calculator's mode. Well, not mode. We'll go to second table set. We go to independent and ask. Now what that means is we can go over here and see how there's nothing here because it's waiting for us to tell it what x to put into the function. We want it to put in 3, you get 23. Now if you want to put in 8, you can put 8. And if you want to put in 1, you can put in 1. 0 and 2 and so on. And we could make a little table of all those values, x and y, and or actually we should put f of x. You put in 3, you get out 23. You put in 8, you get out 5,608. You put in 0, you get out 8. You put in 2, you get out negative 8. And we could just keep putting all these and writing all these results down. And the only thing our calculator is doing here is running all these calculations much faster than we could. As I was saying, you could just keep writing these down, writing all these results on this table, and go on forever and ever. That would take up a lot of room. So another way, and I talked about this in previous videos, what a graph is, but I'll quickly talk about that again because that's something we need to talk about in this section, is graphing polynomials. And a graph is just a picture of these results, right? So if we go to 3, we need to go up to 23 and put a dot. X is 3 and y is 23, and we put a dot there. And if we go to 8, we go to 5,608. We're not even going to bother to graph that point. That's way out there. But at 0, we could go to 8. So that's right around there. Let's see, that's 8. 2, if we go to x is 2, then y is negative 8. So that'll be somewhere right there. Call that negative 8. So put a point there. Maybe we should get some more points over here. So we'll go with negative 1, negative 2, 19, 88. So negative 1 and 19. So negative 1 and 19. 19 is, so let's just put it right here. Negative 2 and 88. That's going way, way up here. So that's too far up there. Let's see, do we put in 1? Let's go 1. We got a 1 here, 1 comma 1. So we'll put 1, 1. Now let's see if we can make a guess as to what the shape of this graph is going to be. We can see that if we went to, negative 2 goes to 88. If we went to negative 3, we'd be at 317, negative 4. Looks like it's just getting bigger and bigger and bigger. So yeah, it's just going to keep going up and up and up from here. If we keep going more negative, the y's are going to get just bigger and bigger and bigger. You can see if we went all the way out to 8, we'd be at 5,608. That's just getting really big. So this is going to keep going like that, it seems, at least. So then it's going to come down through here. It's got to go through this point, through here, and like that. It's something like that. Okay. Let's look. We could look at the graph here. What's the graph look like? That's about what we have here. Yeah, it just kind of comes down. It's a little, wiggly right here, and comes down to the bottom and goes up. So there we go. So that is a not so quick intro to polynomials, evaluating them, right? Putting a number in for x and seeing what you get out, and graphing them. Just taking the results of evaluating and putting them into a graph. Just putting dots at x and y and connecting them. All right, well, thanks for watching.